Okay, hello everyone. It's a great honor to be with you today. And as it was mentioned, unfortunately, I had to stay in Germany for the final negotiation of a triple-digit 100 million euro contract. So what you see on the screen is our second prototype. As it was mentioned, we are building space capsules. So we bring cargo and afterwards humans to space stations around the Earth, around the moon, and then we fly this cargo and afterwards these humans safely back on Earth. Perhaps a few numbers about the company today. We founded the company in Q3 21. We have grown the company quite fast so far. We've raised around about 65 million euro from very good investors. We have won 625 million euro contract. I hope this number will increase in the very coming days. And we've grown the team from 4 people at the beginning to a bit more than 125 as I speak to you. We've built this capsule step by step, and I will present afterwards the first demonstrator that we built and the second demonstrator, which is almost finished. And then we are now starting to go for the final vehicle that will go to International Space Station and then the commercial space station in 27 for ISS and 28 for the first private mission to a private space station. A little bit about the context. It was said already by Peter and by Carlos. We're experiencing really a space revolution, a space exploration renaissance. And one of the main drivers, and I'm speaking really about going to space and so orbit around the Earth and going to the moon, is the huge launch capability which is currently being built by SpaceX, so Starship, which will make it very easy to build new infrastructures in space. Just to give you an example of what is happening, if you look in space right now, you have 2 space stations orbiting the Earth. The International Space Station, which unfortunately will retire by 2030 roundabout. And you have the Chinese space station. So today you have 2 space stations orbiting the Earth. Within the next 10 years, it will not be 2 space stations anymore. You have in the United States 4 private projects of what is called commercial LEO destinations, so private space stations. The front runner is Axiom Space. And then very close in the competition, you have Starlab, which is a joint venture between Voyager Holding in the US, between Airbus in Europe, between Mitsubishi in Japan. You also have VAST, and you also have Orbital Reef, which is a partnership between Blue Origin and Sierra Space. So 4 private players in the US, all probably will not be successful. NASA is going to down select 2 of these players by end of 25 to significantly fund these 2 winners. You also have India developing its space station. India wants to have its space station by 2035, and India is developing currently its capacity to fly humans. Japan also developing its space station. A contract was won by Mitsui to start developing a first Japanese module that will be a commercial module, most probably attached to one of the commercial space stations, either Axiospace or Starlab or VAST or Orbital Reef. And other countries, some countries like Saudi are reflecting about developing their space stations. So these are basically efforts being led either by new space countries, which will become new space powers, like for example, India, or efforts led by private companies in the US, for example. And this is not only happening around the Earth, but this is also happening now around the moon. We have 2 space stations around the moon being built because as Peter was mentioning, the moon is becoming a destination where we want not only to go, but we want to stay at lunar surface. And for that, we need infrastructures, we need living infrastructures. So 1 space station around the moon is being built by the Americans and their partners, UAE, Japan, Canada, the countries of the European Union, as well as another space station, which is being built together by Russia and China. So plenty of new destinations. Fast-growing market, which is mostly funded right now by public money. And most of actually this market is depending on transportation. If you operate a space station, 70% of your costs are transportation costs, because there is a need for cargo resupply, there is a need for human resupply, basically, so that all these infrastructures can properly function. And if you look at the number of vehicles that really can do that, around the Earth today, you have 3 operational that can go up and down. To the moon, to the Lunar Gateway, you have 1, which is called Orion, and I had the pleasure to serve on that program before I left Airbus to build the exploration company. So that's the reason why we said, okay, let's build also another vehicle, a vehicle that can be reused, can be refilled in space, and can serve not only the stations around the Earth, but also the stations around the moon. And this is why we decided to build Nix, which will be actually the first European capsule. We had in the past the ATV that was going to ISS, but was not flying back. So that's really the first time in Europe that we built a vehicle, a product, which is going to station and coming back. This is the first time in the world that such a vehicle is privately funded. And this is also the first time in the world that we are using non-toxic, so green propulsion, to fly such a vehicle. The way we build the vehicle, we think it a bit like Volkswagen, like a family of vehicle. So we have more or less, as much as possible, the same architecture for the vehicle that flies to space station around the Earth and the vehicle that flies to space station around the moon. There are some avionics changes because of the radiation, which are of course not the same if you go to moon or if you go to stations around the Earth. We have an additional engine when we fly to the moon, but as you can see on the picture, we keep the same capsule. We'll be able to keep the same thermal protection, even if there is a difference in terms of heat when we come back from the moon or we came back from stations on the Earth, so that we have basically a lot of economies of scales, and we just need to pay for one development, and we don't need to pay for the development of 2 vehicles. In terms of how it works, it's very simple. We're working like DHL, so we are selling a service, and we buy the launch, which is provided by any heavy launcher in the world. We are launcher agnostic, so we can work with Indian launcher, Japanese launcher, American launcher, European launcher. Then we fly up to the station, we dock, we unload the vehicle. So if it's cargo, it can be repair pieces for the station, which is like a house, needs to be repaired, new solar panels, new material. It can be experiments also, which was performed in space station. It can be also food and beverages for the astronaut. And then we fly back, we destroy the garbage in the atmosphere, and we bring back safely on Earth all the experiments that have been performed by the astronauts or the glass samples that have been collected via the astronauts, so that research can be done also on Earth. And then we reuse the vehicle. So I want to show you a bit of hardware now. We started in September 21. We built in 9 months our very baby capsule that finally will fly on the first flight of Ariane 6 now in a few weeks. We are almost finished. I want to show you some picture with our second capsule that you see here. As you see, it's now fully closed, and we will send for environmental test the second capsule the 22nd of May. We'll go for 2 months of test, and then it will be qualified and ready for launch. So that capsule we will have built in 2 years, because we started building the capsule in July 2022, and we are not yet in July 2024. So it's going very, very fast. To give an order of magnitude, such a demonstrator was once done in Europe, and it took more than 6 years and 100 million. And we did that for, way more. So that's also the new way of working. And then we'll go for the final vehicle that will reach space stations in 27. We will pass the preliminary design review this summer. So what I want to show you also is the lunar engine that we've started to develop. You can see here a test that we've performed 16 months after we started development of this cryogenic oxygen methane lunar engine, which should enable us to go to the Lunar Gateway station around the moon, and also to reach lunar surface, potentially flying in the habitat of Peter. And it's a record that we have broke here in Europe, because in 16 months, we've been able not only to properly ignite and to sustain stable combustion for more than 2 minutes, but also, as you can see here on the video, to demonstrate throttling. We've been able to throttle, so to vary the thrust of the engine from 100% going down to 30% and going up to 110%. And that's a record. Never ever in Europe, a company has been able to build a cryogenic lox-methane thrust chamber, demonstrating throttling in such a limited amount of time. In terms of technology, because we're here to discuss technology, what we make ourselves, we are a verticalized company, we make a lot by ourselves, we make the thermal protection, so we will become a second source in Europe of thermal protection. It will serve our capsule, but also other markets like hypersonic aircraft, so very strategic technology. We start by buying, but we are already developing our own docking mechanism that we make ourselves. All the software, flight software, GNC is something we make ourselves. All the propulsion we make ourselves, and 70% of the avionics we make ourselves, reusing avionics for cars. We perform radiation studies, and then we harden together with partners the avionics at the right level so that it can sustain the space environment, but then we don't have to pay, I would say, crazy costs for space avionics. And as a conclusion, I just want to give a big congrats to the team, because none of that is possible without an amazing team. We've received more than 10,000 applications in 2.5 years. So our company has attracted a lot of talented people, including people who've been working at SpaceX and who decided to come back to Europe and are now serving our mission. And as a bold vision, I would say, well, it's very important for us at the Exploration Company that we continue to bring more cooperation to the world in space. Cooperation is a key European value. And we see with the end of the International Space Station that there is not anymore a symbol of cooperation in space, because stations are being built, but it's in a confrontational manner. Private competition or countries against countries, for example, in the case of the moon. So that's why we've designed our vehicles so that we can be launched by any launchers in the world, and we'll be able to reach any space stations in the world. For the time, we cannot do that with China for political reasons, but technically we can. And I really hope that one day we'll be able to commute between an American space station, a Chinese space station, other space stations, hence embodying in space that the way we build our future as humans is in a cooperative manner. Thank you very much for your attention.